All right, let's go. Good morning, everybody. Good morning. Good morning, sir. So, Group D will be taking our presentation on plasma expanders. So, for the purpose of this presentation, we'll be looking at the body fluid compartments, the properties of plasma expanders, indications and classifications of plasma expanders, the types of plasma expanders, mechanism of action, examples and differences between some types of plasma expanders. Now, the introduction. Plasma is a clear, straw-colored, watery fluid in which several different types of blood cells are suspended. So plasma is blood devoid of blood cells, while serum is plasma without the clotting factors. Plasma expanders are agents that have relatively high molecular weight and boost the plasma volume by increasing the osmotic pressure. They are used to increase or retain volume of fluids in the circulating blood. Generally, plasma expanders are used to replace fluids that are lost due to illness, trauma, or surgery. They do not carry oxygen as they are devoid of hemoglobin. They are hyperoncotic or hypertonic fluids that expand the circulatory blood volume more than isotonic or isooncotic fluids. Typically, colloid solutions are used. However, hypertonic crystalloids are provided for short-term plasma expansion. The total body fluid is about 42 liters and it takes 60% of the body weight. The total body water is divided into the intracellular fluid and extracellular fluid. The intracellular fluid makes 40% of the body weight, about 28 liters, and is two-thirds of the total body weight. It is the fluid enclosed by the cell plasma membrane, while the extracellular fluid makes 20% of the total body weight, that's about 14 liters. The interstitial fluid is 15%, and then the blood plasma is 5%, that's 11 liters and 3 liters. While 75 to 80% is the extracellular fluid is the interstitial fluid. The extracellular fluid is all fluid that surround all cells in the body. The ideal properties of plasma expanders are they are isooncotic with plasma, meaning they have the same concentration with plasma. They are distributed to the intravascular compartment only.
Sorry, John. Put it like this. The ideal properties of plasma expanders should be not are, when you say ideal, nothing is ideal. So the ideal properties should be one, isooncotic. Because when you look at those, you see that none of them is actually ideal. Some of them interfere with blood movement for snatching when you start discussing them.
Thank you very much for that. So they should be isooncotic with plasma. They should be distributed to the intravascular compartment only. They should be pharmacodynamically inert, meaning they are neither metabolized nor excreted, and they do not elicit any pharmacological effects. Then they should not interfere with blood grouping or cross-matching. They should be non-pyrogenic, meaning they should not elicit or induce fever, non-allergenic, and non-antigenic, meaning they should not have any, they should not stimulate any immune response. They should be stable, easily sterilizable, and cheap. And to continue on the indications and contraindications, I'll be introducing Juwon.
Value.
Okay, I said now that we understand what plasma expander is and what ideal plasma expander should be. So I've been introducing us to the indications and contraindications of plasma expander because the contraindications of plasma expander they are usually they can be relative or absolute. So the indications of the plasma expanders. So like so the indications now in one species, so we invariably we use this salad because especially isolating this salad, for example, Venus lactate, because this salad they help in fluid resuscitation in patient that has lung hypovolemic shock. So to prevent patient in going into hypovolemic shock with this salad, patients with severe trauma, surgical procedures to ensure they are hemodynamically stable for the procedures. Then in that and excessive fluid loss. Also the contraindications in patient that has congestive heart failure, renal failure, hepatic failure, pulmonary edema, allergic, and thrombocytopenia. So we won't want to give all these colors because these colors are not to cause they cross match with the blood groups. And if you could remember, know that blood and color they are in 1:1 ratio and crystalline 1 to 2 patients to the drug. So a patient that has renal failure, let's say for instance, this man, they cause renal dysfunction and the kidney is the major organ that excretes this kidney is the major organ that excretes this product. So now imagine patient that has renal failure with acidic comment. So that is an contraindication. Also, too, in hepatic failure, patient that has hepatic failure, you don't want to give inert lactate because inert lactate will cause lactic acidosis and it can induce hypoglycemia. It can induce hyperglycemia. So that will inform our choice in diabetic patients. So these are the adverse effects of plasma expanders, circulatory overload. So heart failure, peripheral edema, urticaria. Urticaria is like skin rashes. So nausea and vomiting, hypersensitivity reaction.
To continue the presentation on plasma expanders, I'm talking about types of plasma expanders and the mechanism of action. That is how these plasma expanders work. So the two types of plasma expanders we have basically are crystalloids and colloids. So the crystalloids, they are aqueous solutions of mineral salts and other water soluble particles. For examples of crystalloids are normal saline, Vegas lactate, Darrow solutions, Bato solutions, sodium lactate, and ORS, that's oral reaction solution. While the second type of plasma expander is the colloids. So colloids are large insoluble molecules such as dextran, human albumin, gelatin, and blood. You should take note that blood is also an example of a colloid. So colloids are better crystalloids. Colloids are better than crystalloids. Why? They are better in the sense that they have larger molecular weight and they are retained more easily in the intravascular space. That is, they don't readily migrate across the capillary walls, and they also increase osmotic pressure. They are also better than crystalloids in the sense that they are effective in resuscitation of plasma volumes. They are effective in resuscitation of plasma volume, which of course colloids can be produced by other crystalloids. Another benefit dextran, degraded gelatin polymer, which is also known as polygelin, hydroxyethyl starch, which is also known as ether starch, and the last one, polyvinyl pyridinol, that's PEP. Then the mechanism of action, that's how do these crystalloids work, how do colloids work. So generally, colloids work by means of osmosis. Basically, they work on the principles of osmosis. Taking us back to the basics of osmosis, what is osmosis? Osmosis is the movement of fluid from a region of lower concentration to a region of higher concentration. So here, how does it work? It increases osmotic, it increases plasma osmotic pressure by drawing water from the plasma into the by drawing water into plasma from the interstitial fluid. For example, as one of the colleagues has said that in one of the indications, like hypovolemic shock, what happens? There is decreased blood volume. So what happens? There's going to be movement of fluid from the tissue into the systemic circulation, into the plasma, and that's just by means of osmosis. So since blood is lost, for example, maybe in bleeding, maybe through trauma or something, since blood is lost, it is displaced in a suitable fluid, which is now it is made to a suitable fluid. Then the now diluted blood flows more easily, even in small vessels. What Shaika told that the blood will now flow more easily, even in small blood vessels. So as a result of these chemical changes, that okay, blood has moved from a region of lower concentration to a region of higher concentration. This is now going to restore blood volume. It's going to restore blood volume, restore the blood pressure, and also tissue perfusion, um, making them reasonable for blood as a plasma expander. Thank you. Moving over with Ben to take us to the later panel.
Okay, good morning everyone. So I'm picking us collect in particular examples of collects and yeah, how they work in the body. So before we move into the collects, it's also important to know the properties of collects. So since we are trying to treat patients, with very sure, we also need to try as much as possible not also cause further adverse effects. So collects they must be non-carcinogenic, they must not interfere with blood pumping, interfere with immune function of the body, it must not interfere with hemophoresis or coagulation in the body. So all these we need to consider it because we are introducing like foreign body, like a foreign company side. So we be sure that they are not actually affecting some properties in the body. And very important, they must not be stored in the body. They must be metabolized and excreted. And their half-life should not exceed like 6 hours. So having made that, we cannot talk about a few examples of product. So first one is the natural product, that's human albumin. So we all know albumin as one of the plasma proteins in the body. Then the other ones include fibrinogen and globulin. So it's the most abundant protein in human plasma, 40 to 50 gram per liter, with a total body content of 4 to 5 gram per kilogram. That is, we have about 4 to 5 gram per kilogram in human body. And the xenophilic non-glycosylated protein with molecular weight of 69,000 dalton. So hydrophilic is also a very good property that we need in plasma expander because we're talking about trying to increase the volume of plasma. So you must have the ability to draw fluid to themselves. So hydrophilic, that is water drawing. They are distributed 1 third to 2 thirds in the intravascular compartment relative to the extravascular compartment and account for 70 to 80% of plasma oncotic pressure. So plasma oncotic pressure, that's the pressure built up by plasma protein and it helps to keep fluid in the plasma, it helps to keep fluids in the plasma. So it also has capacity to bind to cations, anions, and toxins such as bilirubin, which gives it an important physiological role in buffering acid-base balance of the blood. That is in the protein buffering system. It also has a role to play. That's human albumin. So just different from plasma expansion, also have special role to play. So it also has a role to play in regulating the ionized fraction of cations, including calcium, magnesium, and scavenging free radicals and transporting proteins and drugs. We all know that albumin itself binds with some drugs and help them in transporting them within the systemic circulation. So it is synthesized in the liver with a mean half-life of 14.8 days and is degraded mostly in muscles, the liver, and kidney. Just as I mentioned that important classes of products, and they must be excretable and they must be metabolized excretable in the body. So you have that property in human albumin. So hypoalbuminemia from a range of pathologies is a poor prognostic factor. So it is obtained from pool of human plasma, during development of a method to extract albumin in a safe and stable form from human plasma. It can be used without regard to patient blood group and doesn't interfere with coagulation. So one important part of collages is that it should not interfere with coagulation, and we also have that in human albumin. So it is free of risk of transmission of hepatitis because the preparation is heat treated. Still first line. So it's still the kind of first line, but the most important plasma expander that's among colloids that is being used. So it's also free of risk of transmission of hepatitis. So why even the plasma expander also show that we are not trying to transmit infection to patients. So crystalline solution must be infused concurrently for optimal benefit. Now it has a high molecular weight. Then definitely you also need to add crystalloid, just as my colleague mentioned that crystalloid helps to increase the plasma volume directly. It does not have to increase osmosis. So since we have high molecular weight of albumin, definitely we have to give crystalloid with optimal benefits. So it has been used in acute hypoproteinemia, acute liver failure, and there is still you can also use it in what hypoproteinemia when you have reduced protein in the blood or reduced low level of protein in the blood. You can also give albumin in that condition. So it is comparatively expensive. So another group we also talk about is dextran. Now, dextran are groups of branch polysaccharides derived from sucrose by the action of the bacterium Ricinostochilic mesenterics. So dextrans are complex branch polysaccharide with units with a block with the units of glucose. The unit actually form the polysaccharide, the monosaccharides that form the monomers that form polysaccharide is glucose. So we don't have just glucose. So it's a complex branch polysaccharide. So and different dextran preparations are polydispersed mixtures grouped on the basis of their average molecular weight. That is, we have three major types of dextrans based on their molecular weight. So and we have dextran 40 that has 40,000 40 kilodalton or 40,000 dalton available as 10% solution. There's also dextran 60 and dextran 70 prepared as 6% solution. So the molecular weight is the chief determinant of the pharmacodynamics. That is, the more the molecular weight, the more the effect or the pharmacodynamic effect of dextran. So talking about dextran 70, it is most commonly used preparation. Why? Because the molecular weight is 70,000 dalton, so you can show of high pharmacodynamic effect. It expands plasma volume for nearly 24 hours. That means we can have the effect of this dextran 70 for what, a duration of 24 hours. It is excreted slowly by glomerular filtration as well as oxidized in the body over it. And some amount is deposited in the retroendothelial cells just for what? For excretion and for breakdown for metabolism. So dextran 70 has nearly all the properties of an ideal plasma. Now one thing about products is that they must also have their properties must also be similar to the properties of plasma in the body. So they have all the properties of an ideal plasma except these few ones that we have here. One, it may interfere with blood grouping and cross matching. Yes, I mentioned at that time that properties of bullets that must not interfere with blood grouping and cross matching, but not all bullets actually follow all these properties. There are some one or two difference. So first one is it may interfere with blood grouping and cross matching. That's section 70. It can interfere with coagulation and platelet function and thus prolong bleeding time. Some polysaccharide reacting antibodies, if present, may cross react with dextran and trigger an anaphylactic reaction like urticaria, itching, and spasm. If you remember, your colleague also mentioned urticaria as one of the adverse effects of plasma expander. So it's actually specific to dextran 70. So it can react to antibodies, it can cause coagulation, platelet function, affect platelet function, thereby increasing bleeding time. It can also interfere with blood grouping and cross match. So when it's being given to patients, it's important that we observe the patient and we kind of follow up the patient to be sure there is no any adverse effects or adverse reaction. So dextran 40, it acts more rapidly than dextran 70. It reduces the blood viscosity, and it is excreted through the renal tubes and occasionally may produce acute renal failure. The total dose should not exceed 20 ml per kg in 24 hours. And dextrans can be stored for 10 years and are shipped. So are the most commonly used plasma expands. So you can store them for 10 years and you can ensure that it won't be metabolized or their content will still remain the same. So caution, dextran doesn't provide necessary electrolytes and can cause hyponatremia or other electrolyte disorders.
First line there, I think what we wanted to provide is let's transcend it rather than let's process it.
So another plasma expander is degraded gelatin polymer. So it is synthetic polymer of molecular weight of 30,000. It doesn't interfere with blood grouping and cross matching. It is non-antigenic and expand plasma volume for 12 hours. It is more expensive than dextran and can also be used for priming of heart blocks and dialysis machine. So the other ones, the brands that is degraded gelatin polymer are Emasil, Seracin 500 mg/c. So just as been mentioned, they don't interfere with blood grouping, cross matching, non-antigenic, which are important properties of bullets, and expands plasma volume for 12 hours. So now comparing gelatin to whole blood, the gelatin and whole blood almost have the same properties, except when you look at the cardiac cardiovascular value, gelatin will most likely not cause cardiovascular value, but whole blood can cause cardiovascular value. We can also check effects on renal function. Renal function is maintained and improved when it comes to gelatin, but when it comes to whole blood, renal functions might be impaired. So you can also look at several other difference. When it comes to storage, you have 2 to 25 degrees Celsius in preserving gelatin, while in blood you need about 4 to 6 degrees Celsius. So another plasma expander is hydroxyethyl starch.
Hydroxyethyl starch.
Okay, hydroxyethyl starch, which is also referred to as bitter starch. So it's a complex mixture of oxygenated amylopectin of various molecular size. So amylopectin is also a complex branch polysaccharide with glucose as the unit, as the block unit. So and when you talk about oxygenated amylopectin, it's a mixture of it's a mixture of ethylene oxide and amylopectin. Ethylene is alkene hydrocarbon. So it's a mixture of what ethylene oxide and amylopectin. That's how we have oxygenated amylopectin. So that's the average rate of 4.5 lakhs, and it maintains blood volume. It doesn't cause acute renal failure or coagulation disturbance. It improves hemodynamic status for 24 hours. So adverse effects: vomiting, mild fever, itching, chills, flu-like symptoms, swelling of salivary gland, urticaria, and bronchospasm are adverse effects. So the next one is polyvinyl pyridine, that's PVP. It is a synthetic polymer. Polyvinyl pyridine. It is a synthetic polymer of average weight molecular weight of 40,000, used as a 3.5 solution. Polyvinyl pyridine is a polymer formed from monomer of vinyl pyridine. Vinyl pyridine is a compound that contains vinyl and pyridine. So PVP was used as blood plasma expander for trauma victims after the 1950s. It interferes with blood grouping and cross-matching and is histamine releaser. So when it's histamine releaser, that means it can actually cause adverse reactions. It can cause like hypersensitivity reaction in the body. And it binds to penicillin and insulin. It is excreted by kidney and small amounts by liver into the bile. A fraction is stored in the reticuloendothelial cells for prolonged periods. It is less commonly used plasma expander. So that was all. Thank you.
Let me interrupt this and start refreshing just so that I don't have to start splitting